Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. Yes! Day 2 is out and we got some waves on the first one. That's interesting. So let's look at day 2. Rock, paper, scissors. The elves begins to set up camp on the beach to decide whose tent gets to be closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is the game between two players. Each game contains rounds. Each round the players each simultaneously choose one of rock, paper or scissors using hand shapes. Then the winner of the round is selected. Rock defeats scissors, scissors defeats paper, paper defeats rock. If both players choose the same shape, the round instead ends in a draw. So normal rules for rock, paper, scissors. Appreciatively of your help yesterday, one of the elves gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column you reason must be what you should play in response to X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score of a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors. Plus the score for the outcome of the round, 0 for loss and 3 for a draw and 6 if you have won. Since you can't be sure if the elf is trying to help or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you have the following strategy guide. This strategy guide predicts that and recommends the following. The first round your opponent will play rock and you should play paper. This ends in a win with a score of 8. 2 because of paper and 6 because you won. In the second round your opponent will choose paper and you will choose rock. This ends in a loss for you with a score of 1. 1 for I guess the rock and 1 for rock and 0 for the loss. The third round is drawn with both players choosing scissors, giving you a score of 6. In this example, you were following the strategy guide, you will get a total score of 15. What would be the total score if everything goes exactly according to your strategy guide, your puzzle input? Interesting. So we have a bunch of different things that we need to keep track of here. We need to keep track on if it's a loss, draw, or if we won. We need to keep track on what shape it is, because that has different values. And we need to keep track on what is what as well, which makes things a little bit, could be hairy because there is a lot of terms here, and if we do something wrong we will get a skewed result and it could be hard to debug. So I think we would need to do this very carefully. So in order to get this squared out here, we could have let's say, let's do some final int here, and we say rock paper scissors. Is that the correct spelling? It doesn't really matter, but yeah. Rock paper scissors, and we should have 1, 2, 3, and then we could have 3 more here. Loss, draw, win. So we have all the scores handled, and then we could have a map of values. And these could be string to integer, or shapes. Shapes. New array. No. Array list. Oh, can't have an array list. We must have a hash map. Hash map. That's what I was thinking. It's a map. So the shapes we have, if we put values here, we have A, which is rock, right? Let's see if that is correct. Why can't I have rock here? So let's see. X for rock, Y for paper, Z for scissors, A for rock, B for paper, and C for scissors. Okay, so it's B, Z, B, Z, scissors, and paper. Let's do integer here and see if that integer, does that help us with the non-static field? It could not be referenced. Yeah, of course. Final static. It's a static context that we're using. So final static context. So now we have those shapes, and we also need X, Y, Z. Is that correct? X, Y, Z. Yes. So now we have handled all the shapes. Now we can take this little example test data here, like that, and score equal to 0 here. And when we read the line, let's see how the other, so this is just a very much longer similar thing. So line is split by that. You can do a trim on this line as well, like that. String match. So these are the two values of the match. So match 0 is the opponent, and if we get shapes and we get our opponent's score here, So which one was it that we wanted to count? The shape you have selected, okay? So if these two are equal, so our shape and their shape is equal, then it's a draw. So score should be increased by a draw value. And then we can do an else. If we take the winner on the left side, we should have 1, 2. I wonder why it wants to do that. And then 2, 3, 3, 1. So that's the winning conditions if all the winners are on the right hand side, right? So scissors, rock wins over scissors, paper wins over, scissors wins over paper, and so on. So here, if that is 1, equal to 1, and other one is equal to 2. Three, 2, 3, 1. So those are the winning conditions. And then we have an else. There is a loss. And loss is 0, so we don't really need to add that up. So now we have the calculation of the score. If we take the score down here and print it out, we should have 15. If I haven't screwed something up. So let's see, let's run the right day here. 9. So I did screw something up, of course. And that's because I haven't added my value. So shapes get match 1. So I need to add my value as well. So then I get 15. So that seems correct. Let's try it with the large one. Index out of bounds. Here we have an empty row at the end. So let's handle that. If match length not equal to 2, continue. Now we can try. So then we got 13,809. So let's try that one out. Put it in down here. Submit. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. So let's do part 2 then. The elf finished helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw. And Z means that you need to win. Good luck. The total score is still calculated the same way, but you now need to figure out what shape to choose so your round ends as indicated. The example above goes like this. The first round your opponent chooses rock, and you need the round to end in a draw, so you choose rock. This gives you a score of 4. 1 plus 3. In the second round, your opponent will choose paper and you choose rock. So you lose with a score of 0. In the third round, you will defeat your opponent's scissors with a rock for the score of 1 plus 6. It means 7. You now are correctly decrypting the ultra top secret strategy guide. You should get a total score of 12. The following the elf's instruction for the second column, what would your total score be if everything goes exactly according to the strategy guide? So this is actually easier. So you lose if you have an X, you win if it's a Y if it's a draw, and Z means that you need to win. So if we do a second score here, int pred score, so prediction score or something like that. So that is still the same value down here. We need to add the shapes value. And then we only need to check if the match is, or the match 1 is equal to X. What outcome did we have? We can copy this sentence down here. X means you lose, Y means you round in a draw, and Z means that you win. Good luck. So X means you lose. So then the pred score is increased by lose. And then we have the other ones here. Y means that you draw. And Z means that you win. So that is the same thing, except that we go for the second score here. So if we print that out, so we need to figure out what we actually choose, because the second shape here is not what we choose. That's the problematic thing. So we need to add it in here. So here we have a loss. And if we go by this table up here, so here's the loss, and in this case, if this shape up here is equal to a rock, yeah, so the easy one is the draw, right? So the draw should just be the same value down here. So that's an easy one. So if the shape is rock, then the pred score we should add is scissors. And if they choose paper, we should choose rock. And if they choose scissors, we should choose paper. So now we have the loss score here. And the same for the win. If they choose rock, we should choose paper. If they choose paper, we should choose scissors, and if they choose scissors, we should choose rock. So pretty simple. As we have all of these stated, we can have if statements for each of these different cases. We could have done case switch statements as well, but I don't think that would have been so much shorter. So as we know, keeping track of all the terms here, I'm fairly sure that this would be the right value now. 12,316. Let's try that instead. Yes, you get a gold star, I get a gold star, everybody gets a gold star. Oh, Jesus. So we had a little bit of a bug there, but I think this code is pretty easy to follow. For the second case, we needed to figure out if we should lose, we should win, or if it should be a draw. In the case we should lose, we add the lose statement, and then we have if statements for each of the ways we can lose. So we add our way of losing. And then we have the y, where we should make a draw, and then we just add the same shape as they had. And then in the case where we should win, then we need to figure out each of the win conditions and add those. So I think I hope this is easy to follow. I hope that you found this interesting. I hope that you learned something today. If you liked this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave them down in the comment section down below. If you have a totally different way of solving this, please leave some code down there as well. I would really like to read it. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.